Good afternoon, everybody. Can you see my slides? Somebody shouts yes, please.
Yes, we can.
Yes.
Okay, the captions are on. To move this. All right, so second day of my 3 lectures. Today we're going to talk about the principles of realism-based ontology and focusing a little bit on biomedical ontology. So from Monday, you remember that there are different kind of representation systems, all of which are called ontologies, and that we can divide them to the extent that they are directly useful for people or directly useful for computers. So realism-based ontology are on this end here, so they are most directly useful for computers and a little bit less for people, unless they understand, of course, the formal aspects of the language in which these ontologies are designed. I also show this schema, which shows how you go actually from reality, the perception thereof, over conceptualization, the expression of reality by means of some language, and how that can give rise to either good or to bad ontologies. So there are 2 principles that in the development needs to be followed. There are the ontological principles, and that is what we will talk about today. And there are the logical principles. That's what I talked about on Monday. If you did not attend the lecture on Monday, then I recommend that you look at the video if there are parts of today that you do not understand. And certainly also for tomorrow, I will demonstrate how by using some practical tools, you combine those 2 to design an ontology. So learning objectives for today, primarily the principles used in the basic formal ontology, which is an upper level ontology that has been designed so that it can accommodate all domains. We will briefly touch upon the OBO Foundry and the bioportal ontologies. The main part will be, of course, describing those realism-based principles, which are on the basis of the BFO. And when we have enough time, then we will also dive into the ontology for general medical science, which is an ontology which uses the BFO as an upper ontology. If we don't have time, don't worry about that. I will leave the slides in there and you can watch them afterwards. In any case, what I would like you to be able to do is to understand also that distinct non-realism-based ontologies rarely use the same set of principles. So it is not just an aspect of realism-based ontology that it uses principles. Most ontologies use principles, but not all ontologies use the same principles, and that might make them incompatible if you try to combine them, or for work which is based on other principles than the ones that the ontology has been designed for. So general principles, there are 2 aspects: what to represent, okay? And the principle here for realism-based ontology is that you base it on the philosophical discipline, okay? The basic principles to classify what exists. And then how to represent it? Well, that's formal representation, which we covered in part Monday. Be aware ontology is much more than classification. Okay, classification itself is based generally on properties that are said to be shared in common by certain things. Properties are, for instance, being human, being pregnant, being poisonous, whatever you can think of, or having cancer, having a parent, having mass. Okay, those things are all properties. It is not by coincidence that you see that many of the properties, when you express them in natural language, that they actually start with the gerunds like being or having. Okay. Now, an ontology in mainstream, the mainstream view of ontology is merely a classification. You will usually see, even if you open the interface of Protégé, in which most ontologies are built, you will see a hierarchy in there, and that's a classification. Okay. But of course, an ontologist should be more than just a classification. Now, what this makes realism-based ontology distinct from mainstream ontology, that's is in the fact that in realism-based ontology, the properties themselves, they are analyzed. And you have to ask yourself certain questions. For instance, if X has property P, can X exist without P? Think a bit about that. An example would be if something has a shape, can that something exist without a shape? And let that something, for instance, be me or you, okay? If you have a certain shape, can you exist without that shape? Or another one, if X acquired property P, can X ever lose it? Well, there are for certain things, for sure, having diseases, okay? If you're having a disease or having cancer, if you consider that to be a property, it's one of the properties that hopefully you would lose when treatment is given. But can an object or a person, can a person lose his weight? Or let's say his mass? Of course, if he goes in outer space, he can lose his weight, but he cannot lose his mass, okay? So that fact, whether properties that you can gain and lose, in contrast to properties that you cannot gain and lose once you have them, okay, those are already important differences, and that will be used in the way that realism-based ontologies are built. Or another one, can X and Y share, for instance, property P? Okay, can two different people share the same anger? Or can two different shirts share the same color? Okay, and here we need to be careful with the terminology in using same. I use it here as exactly, okay, the same, having identity. Okay, so those are those elements that we will discuss a little bit more in detail. Important is that in your realism-based ontology development, that you try to mimic the nature of things in the representation of those things. Take, for instance, this statement here. Imagine that in your ontologies, you need to represent that some berries are red. Okay. So on Monday, I explained to you the principle of using the common logic interchange format. We will use that again today. So this statement can be expressed in first order logic like this. There exists an X for which it is the case that berry can be predicated about X and red can be predicated about X. And I say specifically predicated about because in this case, berry and red are represented as predicates, okay? And the X is a variable. The and is a logical connector that is allowed to be used in first order logic. And the exist is the quantifier. Now you can also do it this way. Okay? There exists an X and you predicate berry about X, and there is a predicate which relates X to red. Or you can do it this way. There exists an X and a Y. And you predicate about X that it is berry and about Y that it is red, and that there is the relationship has color that obtains between X and Y. You can do it this way. You can say, okay, there exists an X and a Y, and X is an instance of berry, and Y is an instance of red, and X has color Y. You can do it this way. You can add time. So now we need three variables here. There exists an X, a Y, and a T, and X is an instance of berry at T, Y is an instance of red at T, T is a temporal interval at T, and Y in here is an X. So this is realism-based. Okay? So the difference in going from here to here is that you go here where you have purely predicates, like the properties in the mainframe sense. So berry and red are here properties that you can read as being a berry or being red. But the difference that you see is that in both cases here, the property is assigned, those two properties are assigned to the same thing, that X. While here, they are assigned to two different things. Okay? So the color itself, okay, not the redness, but the color, okay, Y in this case, is an entity in its own right. Just like the berry is an entity in its own right. Okay? So whenever you do realism-based ontology, you need to build yourself on a certain ontological commitment, okay, which is what are the sorts of entities that you accept that exist in the world and that you want to represent. And the more detailed that you go like this, actually, the more you can express in your ontology, the better you can represent your relationships and so on. If you do not include time, okay, which is not possible when you use binary relationships only, okay, well, then those statements here, like this one here, that might be correct. But if you are following a specific berry, you know very well that most berries, they don't stay red forever, okay? Tomatoes, they start usually as green and go over red. Bananas, they start as green, become yellow, then brown, and so on. So properties can change over time. If you are detailed, then you can represent those various aspects of it. Like I said Monday, if you have any questions, shout. Yes, I can't pay attention to little hands that go up.
Professor, I have a question.
Yeah.
Is it possible to do like a hybrid in the case of like having berry be an instance of, but then has color for, because like it seems like having every color be a specific instance seems like it might be inefficient. So can you do a hybrid having an instance of and has color in both?
Well, but then you still, if you are going to write your axioms, you still have to express what the relationships are, right? Because otherwise, if you express it in one way and you do it for another in another way, they are not comparable. And at the other hand, you touch an important part. So it is a characteristic of realism-based ontology that in the first place, we don't worry about efficiency, okay? What we worry about is correct representation, adequate representation. And then the efficiency that comes later. That's a problem that actually computer scientists have to work out. Okay?
Okay, thank you.
So is this definitionally what you mean by realism-based? Is that the properties are all basically entities?
Yes. So we don't work with properties at all. Okay. So we look at what are entities. Take the color of my shirt. Okay. So my shirt is an entity, but the color of my shirt is also one. Okay. Now that color of my shirt is an instance of black. And well, if you know me, you know that I only wear black clothes. But my different shirts, all of which are black, right? They do not, none of those shirts, okay, its color is the same as the color of another shirt. It's exactly similar in most cases, okay? So we consider in realism-based ontology things like qualities, entities in their own right, and they relate to the other entities in which they inhere, okay? So that's why this relationship is here, inheres in. And both those relationships and the entities, they are all defined as much as possible. Some, of course, we need to introduce primitives because you need to start somewhere, but we try to define them as maximally as possible. Does that answer your question?
Yes, thanks.
All right, others? No? Okay, let's continue. So what entities are there, right? So that's exactly the basis of the entire problem. So we are gonna not look at all the kind of entities, but we are gonna look primarily to essential distinctions that you need to make. And one of them is reality versus representations, and the second one is particulars versus types. Okay? So let's start with the first one. Portions of reality. So those portions of reality, I mean parts of what exist. and representations thereof. So imagine that this is a real operating theater, right? And that this would be a window when you are looking through it. Okay. Well, then you see really reality what is going on. But this, instead of being a window, it could be an image, video capture of what is going on there. Okay. In that case, this is a representation. Well, that is the reality. Okay. If the cameras are positioned in the right way and they have high quality lenses, then you see exactly here what is happening there as if you are looking through the window. You can't see, of course, what the surgeons are seeing here because the angle of the camera is different. But if you are looking through the window from this perspective here, then you can't see it either. Okay? So this is reality, that is representations. For videos and for pictures, it's pretty clear. But it is also the case for data. Okay? When you are collecting data about reality and you represent what you observe in reality by means of numbers or terms or whatever, so you use spreadsheets for that or whatever, okay, this is representations, that is reality. And in the ideal case, okay, by looking just through the data, you should be able to infer what must have been seen there. And if you have a lot of imagination, then you can indeed see in the data what is going on there. That is at least if the data are detailed enough, well structured enough, in the sense that they mimic reality. So, yeah, was that a question? Okay, sorry, I thought I heard something. So again, here we have reality, and we call the reality the reference. Reference because they are referenced by our terms or by classes, by words, and so on. Reference are metaphysically the way they are, okay? And they relate to each other in an objective way. What we mean by that is that whatever you might think about it, okay, entities are the way that they are. They follow the law of nature. We have our window on reality, okay? Our window are our eyes, our ears, our noses. We also have instruments, okay? Now, that window in reality is restricted by what is physically and technically observable. That has changed over time. 600 years ago, they couldn't see bacteria, okay? Now we have a very strong microscope and we can see certain atoms. That window is also restricted by the fit between what is measured and what we think that is measured. Psychology, for instance, has a huge problem there. There is nothing there that they can see. So they develop constructs, and then they try, by looking at behaviors and those kind of things, they try to make statements about those constructs and how those constructs relate to each other. But as currently what is really going on in the brain and how it exactly works, that's a big mystery, okay? So psychology is the last thing, actually, that you should put in a realism-based ontology, because there is nothing that you can really observe. The only thing that you think that you can observe are those constructs that you are building. Neuroscience will probably change that in 200 years from now, who knows? Last restricted thing is the fit between established knowledge and laws of nature. So it always says that whenever you do a discovery or a thing that you invented something or discovered something, it must fit with what you already know. The problem is, of course, that you can never be shown that what we demonstrate that what we think we know is actually correct. So it might be that the knowledge that you have about reality needs to be changed regularly as well. And then we have on the right-hand side the references, okay? So references, they follow ideally syntactic semantic convention of some representation language, okay? Like logic or whatever formal language. References are restricted by the expressivity of that language. I talked Monday about the limited expressiveness of OWL and description logic as opposed to first-order logic, and the limited possibilities of first-order logic as compared to secondary-order logic, and so on. Also, references the collections thereof need to come for correct interpretation with documentation which is outside the representation. Okay, you must know what exactly the syntax is, what the grammar is, if they are combined, what rules you are allowed to follow when you work with those references. Google is really nice for that. So this is a satellite view on the Niagara River here. Here you have Canada, here you have a part of Buffalo, and I am teaching currently just here outside this image, somewhere here. So this is the satellite view, and you see streets, you see the bridge that connects Buffalo to Canada, you see the streets, you see some houses and so on. This is the map, okay? And you can overlay that exactly, okay? So in that sense, a Google map is a quite adequate representation of the underlying reality, okay? This is a very good representation of that, but not everything is, okay? Do you see, oops, I overlaid them here. Do you see this line here? This line is the border between Canada and the United States. That line is not there, okay? Now, if you look at the river, you see that here, right? I have absolutely no idea what that is. Is that something in the water? Is that something in the air, clouds, okay, from that you see from the satellite? The fact that this line here, okay, corresponds exactly, is highly correlated, okay, with those white things there is pure coincidence, okay? It's pure coincidence. That's what I mean when I say that a representation should be faithfully represent reality. But by looking at the representation only and looking at reality itself only, you might be misled, okay? And therefore, again, you need to have certain principles which we discuss. So the second distinction is between particulars and types. So I prefer to use the name type in certain circumstances to denote something which is generic, okay? So in mainstream ontology, you will use different kind of terms. You use concepts or kinds and categories or classes or prototypes, and they all have their different flavors and their own definitions, and sometimes you can compare them or correlate them, otherwise, and sometimes you cannot. In realism-based ontology, we use type usually for two different kind of things. So one are universals, and universals, they are those elements which come from the doctrine in philosophy, which is called realism. Okay, the commitment that generic things really exist, like human being. And we also put under types defined classes. An example would be a human being in Buffalo. When we use class, we mean an extension of a universal or a defined class. For instance, all human beings, the collection of all individual human beings. And that is not the same thing as the universal human being. So for the reference, okay, so the things that we talk about in realism-based ontology, we talk about particulars. Sometimes are used as synonyms, individual or instance. Okay? Particulars are individual entities that exist or existed in space and time, that exist only once, and that carry identity. Okay? If you have two identical shirts from the same maker, okay, they are identical in the sense that they are exactly similar, but they are not identical in the sense of particulars. You have two different particulars, two different individuals, okay? Both are instances of shirt. So a type is a counterpart in reality of some non-empty general term used in the formulation of some scientific theory. So that non-empty general term means actually it is something that must really exist, okay? So devil is an empty general term. Klingon is an empty general term. Cancer isn't. That's non-empty. Universal that's a type which has particulars as instances. Or we also say that universals are instantiated by particulars. And that's why you have that synonym instance here for particular. By class, we mean the extension, which is the maximal collection of a non-empty general term. You should time index that as well, okay? Because the class of human beings changes like every second, right? Every second somebody gets born or dies. So the class stays, the maximal collection stays, but it changes over time. The universal doesn't change. And then the defined class is a collection of particulars defined by selection or combination of terms denoting particulars or types. Like the example that I gave, citizen of Buffalo, of human being living in Buffalo. So we have universals, we have particulars. Okay? There is a barrier between them. Nothing which is a particular can ever become a universal or the other way around. Okay? If you read the what's the thing there, the Ontology 101, which is one of those introductory courses that you can find on the internet, there will at some part you will see that you have the choice whether define something as a class or as an individual. Well, from a realism-based perspective, that's totally wrong. We will get into that. Particulars are instances of universals, and they are instances at a certain time of some universals. For every universal, there is or has been at least one instance. Every particular is an instance of at least one universal. The universal particular declaration is in BFO, for instance, expressed in this way. At all times, there is at least one particular and one universal that is instantiated by that particular. And the first order logical axiom that expresses that is here. So here we have different particulars, okay, and we have the universal human being. These human beings are instances at a time of human being, okay. Probably they were not all the time, okay. At some point, this fellow here was a zygote, right? And a zygote is not an instance of a human being. Now, remember the first distinction that I made. Can I change this slide? Very slightly change one thing and still be incorrect. Now, I said these are human beings. It's actually not true, right? They are photographs. Okay. So, but whenever we depict something, it is important to know what are we exactly talking about. Okay. So, are we talking about these human beings, or are we talking about the pictures of those human beings? And if you think again in terms of properties, okay, the properties of pictures are totally different than the properties of human beings. Never confuse the two. So I started by saying what classifications were in the mainstream approach. So in BFO and in realism-based ontology, we work, of course, with classification in a certain sense. What is important to understand is that it is the instances that are the objects of the classification. So we are not classifying the universals. We use universals to express what is the case for the instances or for the particulars that instantiate them. But we are not classifying universals. BFO is not a classification of universals. It has a classification of instances of individuals. Okay, so this fellow here, if we look through the picture and see him, then that guy is at a certain time an instance of human being, and while he is instance of human being, is also an instance of mammal, of vertebrate, of organism. Okay. So that brings us to that formal definition in the BFO of ISA of also known as a subclass of. The subclass of is what is usually used in OWL and description logic. So the is a relation is the subtype or subuniversal relation between universals or type. Okay, so when we say C is a C1, it is defined as C and C1 are universals. And for all C's, where we use small letters here, now we are talking about individuals, for all is quantified, right? So for all C and T, if C is an instance of capital C at T, then C is an instance of capital C1 at T1 at T. Okay, so that is the definition of ISA in the BFO. Now, if you look at the BFO and the full axiomatization, you will not find ISA as a relationship there. That is because, like I said, we classify individuals. So to express that classification by means of axioms, we use these kind of statements here. Okay. So for all T and X, if X is an instance of a specifically dependent continuant at T, then X is an instance of a continuant at T. And the same for quality and the same for relational quality. And because we do it, so if you interpret that, okay, now you can indeed say that a specifically dependent continuant is a continuant, and that a quality is a specifically dependent continuant, and that a relational quality is a quality. But mind you, time indexed, okay, time indexed. BFO comes in two versions. So you have the first order logic axiomatization and you have the rendering in OWL, okay. If you use the rendering in OWL, that time aspect is lost, okay. It cannot be expressed. But still, when you would use the BFO rendering in OWL, you should still use it only in the sense as if it were time indexed, okay? And never say that an A is a B when it is not necessarily at the same times. Okay. So it is therefore, because this guy instantiates at the same time all those universals, it is therefore that we can express that also briefly by using the ISA relationship. So in RDFS or in OWL, that is not the case. Okay, so in there it is exactly the opposite. So what you do there in that language, you define first your subclass of, and then you combine. Okay, while for the realism-based approach, it is exactly the other way around. It is because all the instances are such that they instantiate different kind of universals at the same time. Therefore, it is that we can use the ISA. So do not invert that. And like I said, there is also no time indexing in the BFO. So earlier, I thought I had a slide about that, so here it is. Whether something is a particular or a type is not a matter of choice, okay, but it is a matter of reality. Okay, so we've in that thing from Introduction to Protégé, we read, for instance, for example, we can create an individual instance, Chateau Morgon Beaujolais, to represent a specific type of Beaujolais wine. So you can do that indeed in Protégé. Protégé allows you to have an universal, sorry, not a universal, but to have a class as an instance and so on. In realism-based ontology, you can't do that. It's not necessarily logically wrong, but it is ontologically wrong to do that. There are different classification systems and terminologies out there, okay, that quite often are confused with ontologies, and definitely they do not follow realism-based ontology principles. Okay, take mesh, for example. Now, mesh itself doesn't claim to be an ontology, but you have certain witties who then take mesh and they think that they are expressing it in OWL and then publish it somewhere, and then you have mesh ontology. Well, no, actually it isn't. Okay, so for instance, look here at Europe. Okay, so why, if mesh would be a realism-based ontology, okay, what would be wrong with having Europe here? Can you tell me? Europe is an individual, okay? There are not different kinds of Europes, okay? there are different kind of geographic locations. Right? There is this location and there is that location. But there is only one Europe. So Europe is an individual. It's not a type. Okay. So now, of course, they can say, well, we mean that this type has only one instance. Okay. Okay, if you want to work like that. But if you do that, there is another problem. Okay. And it's exactly related to what I said with respect to the previous slide. What would be the next problem? The next problem is that particulars cannot have particulars as instances. Okay, if you say that Europe is a particular, then Andorra cannot be a particular in Europe. What would it be? Okay, Andorra is not a kind of Europe. Austria is not a kind of Europe. Okay. If there would be a part relationship, okay, mereological relationship, then you could indeed say, yeah, Andorra is part of Europe, Austria is part of Europe. Okay, but it's not a kind of Europe.
So Professor, would it be more correct then to say like European country, and that would be a correct type instead of just saying Europe instead in general?
Exactly. Yes. So European country would be fine. In that case, you would have a defined class, like a human being living in Buffalo.
Got it. Thanks.
And now you really need to express that Andorra are instances thereof. Okay. So you can't do it with one hierarchy like this. So that's why I call this subclass overload. Okay. So there is the subtype relationship, and then there is the partonymic relationship. And you need to distinguish the two. You cannot bring them in just one hierarchy. So the importance of that particular universal distinction is that ignoring the distinction may lead to assertions in which different interpretations are possible depending on which terms intend particulars and which universals. Okay, so take this example. So this is from the International Classification of Headache Disorders. So it has a term which is called persistent idiopathic facial pain, which is defined as persistent facial pain with varying presentations and then some other things that are not relevant here. By the way, this is the case that we are going to work out tomorrow in axioms and show how that exactly works if you want to do such complex things. Now, that classification is used for by clinicians. Okay, so when they see a patient with some pain in the face, clinicians need to decide, okay, whether that patient has a disease which is called persistent idiopathic facial pain, and on the basis of the definition. Now imagine that you have 3 patients. All 3 have continuously facial pain. Okay, it's persistent. The first one has always pain which presents itself in the same way. The second one has also always pain which presents itself in the same way, but in a different way than in the first patient. So the first one the pain might also always be dull, and for the second one, it might also always be throbbing. And then the third patient, the pain presents itself sometimes like in the first patient, sometimes like in the second patient, sometimes different from those. Okay. So which of those 3 patients satisfy the definition for persistent facial pain with varying presentations? That's the problem that the clinician is faced with. Okay. Well, it's ambiguous. The problem is that this definition is ambiguous because of ignoring the type instance distinction. Okay, so we can represent it like this. So here you have types. Okay, you have the type persistent facial pain, and then you have presentation type 1, presentation type 2, and so on. And here you have the particulars. Okay, my pain, her pain, his pain. My pain in here, if I have it in me, her pain in here, in her, and so on. If you believe that pain is equality, at least. So my pain would be such that at all times it is persistent, and at all times it has presentation type 1. Her pain is such, it's all the time persistent, but at time T1 it has presentation type 1, and at T2 type 2, and so on. And his pain is always like this, always persistent facial pain, but always of this type. Okay. So if the description here is about types, in that case, the 3 particular pains would fall under PIFP. But if the description is about arbitrary particulars, then only her pain falls under PIFP. Okay, because this is the only one for which in that patient the presentation varies. But if you look at the varying presentations over all patients, okay, then they all satisfy that definition. So a second point, if you ignore the distinctions, is that sometimes authors run together forms of speech governed by different logical rules. Okay? So this is again an example, a clinical example. Okay, so there is a paper here by a couple of experts in bruxism. So bruxism, that's that disorder when people clench their teeth at night, and that can be mild, it can be severe, so that their teeth break and so on. So that's called bruxism. So we can read stating that sleep bruxism is a behavior in no way precludes the possibility at some to be specified and validated cut point of it being more than a behavior, either a risk factor or a disorder. Okay, so that by itself is already a little bit puzzling, right? So how can something in some cases be a disorder and in other cases be a risk factor, right? Or the second statement, bruxism is a continuously distributed behavior. So let's analyze that again in light of that distinction. Okay? So this is a statement about universals. Bruxism is a behavior. Okay? So we had it here. Bruxism is a continuously distributed behavior. Just make it behavior to start with. So now you have John's repetitive jaw muscle activity of last night, which is a process. Okay, and because the process happens in a certain way, therefore it is bruxism. And of course, it is then also an instance of behavior. So now let's try to put that continuously distributed behavior in there. So the simple way would be, okay, you are more precise about that behavior. So continuously distributed behavior would be a kind of behavior, and bruxism would then be a kind of continuously distributed behavior. But does that make sense? Does it make sense to say that John's repetitive jaw muscle activity of last night is an instance of something that is continuously distributed? Because what they mean by continuously distributed is being different in different patients, right? So that doesn't work. That doesn't work. Because this bruxism and behavior is in all particulars that are instances of bruxism, but the continuously distribution is not. Okay, it's rather a type of universal. Okay, so a construct that is outside the particular universal realm. Which brings me back to what I said earlier. Okay, so even in the BFO, we are classifying instances. We are not classifying types. Now you can classify types, and in that case, continuously distributed behavior would be such a kind of universal, okay? But it would not be a universal. Language is a little bit difficult here to explain. But imagine, think in temperatures, okay? Temperatures are such, or body temperatures, that they are always between a certain, for a person being alive, certain minimum temperature and a maximum temperature. If you go out of that range, you are dead, right? Or burning. Now, but if you take individuals' temperatures, okay, you will see that they are slightly different, okay? So they are also continuously distributed over different patients, okay? That bruxism here, continuously distributed behavior, what they mean is exactly in the same sense. So it can be very mild so that the clinician doesn't need to do anything about it, or it can be very severe, so that the patient should at least put one of those things in his mouth at night so that he doesn't clench his teeth too much, so that they don't get damaged. Okay, so 2 examples of why it is important to have that distinction between types and particulars. Questions? No? Okay, so let's now look to the basic formal ontology itself. Okay, so I discussed thus far some realism-based principles. Now we will see how those realism-based principles are used in the basic formal ontology. These are 2 major references. There is a book that has been written in 2015. Unfortunately, it's not up to date anymore. It was way before the axiomatization, but it is still valuable to read it, at least to have a good idea what it is all about. BFO became an ISO standard a couple of years ago. And here you find the reference to that standard. Be aware. BFO has many phases, okay? So you have the textual definitions, like an object is a material entity, okay? With a definition, you will find that somewhere for all x, t, etc., okay? Actually stating that everything which is an object is a material, everything which is as a time is an object is at that time a material entity. You have the BFO OWL, okay? Which is expressed in this way, okay? There is no time indexing here, okay? So you lose that time indexing in OWL. You have the BFO 2020 first order logic axiomatization, where you have everything, okay? You do not just have the definition about this, but you have several axioms that actually work together, okay, to make that definition concrete. This is the one that you should focus on, okay? Even if you intend to use BFO as OWL, okay, please read the axiomatization, because it's only that one that you makes you aware fully of what is actually intended. The OWL version is just approximate. So what entities are recognized? Theoretically, okay, you have entity on the top. Now in the axiom, that's what you will see in the OWL ontology. Now actually in the axiomatization in first order logic, you do not have that. Okay, why is that? That's because there is a problem with the word entity in ISO standards. Okay, therefore in the first order logic axiomatization, entity became a predicate, just like particular and universal. Okay, it is not a kind of a thing about which you say that it is an entity. What we do say is that occurrence and continuance are entities. But okay, making abstraction of that, an entity is anything that exists or has existed or even will exist. Okay, why do we do that? Well, the BFO actually follows the eternalism principles, which actually say it looks over time in total. Okay, you can actually express in BFO that you would be very happy to have a son in 5 years from now. The sun still doesn't exist, right? But nevertheless, you can express it precisely because of that time indexing. So what are the kind of entities? Continuance versus occurrence. That's the main distinction. Okay? Roughly, continuance are things like me, my intelligence, my heart function, my instructor role. Okay. And occurrence are my life, my reasoning, the functioning of my heart, my teaching, and so on. And you see, I didn't select them purely at random. You see already a certain relationship between me and my life, my intelligence, my reasoning, my heart function, the functioning of my heart. So we will get into that. Continuance and occurrence are totally separate. Nevertheless, they are related in very precise ways. Okay. So in BFO 2020, I said universal, particular, and entity, all 3 are unary relations. Okay, so we express that, for instance, like A is a universal, B is a particular, B is an instance of A at T. Continuants are entities that at any time that they exist in total. Okay, I exist now in total. Oops, I lost another hair a second ago. Despite that hair now being on the ground, I still exist in total. Okay, I do not have all the parts anymore that I had a few seconds ago. Oops, there goes another one. Okay, but at any point in time, I exist in total. Occurrents are not like that. Okay, at any time that they exist only partially. If I wave my hand, okay, that's an occurrence. My hand is a continuant. The waving of my hand going back and forth is an occurrent. Okay, there is no moment in time, okay, that my occurrent exists in total. Okay. We can make an ontological square. Okay, so take again the distinction between types and particulars, and continuance and occurrence. So types are tooth and teeth grinding. Think again the example of the bruxism. So you have my left maxillary first molar, which is a particular. My teeth grinding is a particular, and wrong direction. And my left maxillary first molar is an instance at a certain time of tooth, and my teeth grinding is an instance of a teeth grinding. In the book from 2015, you will see that instantiation of occurrence, okay, is not time indexed. That has been changed. You need to be aware of that. If you read the book and you compare it with the ISO standard, then in the early days, instantiation in occurrence was not time indexed. And there is something to say for that. So I'm not saying that that was wrong, or I'm also not saying that it is wrong to have it time indexed now. Two different options, but you need to be aware that the options have changed. Continuants, they preserve identity while changing. Okay. So this was me when I was a year old. My mother was very proud because she won with me the award of the most beautiful baby of the county. You see how things can change, right? That is me a couple of years ago. I was an instance of child in 1960. I'm an instance of adult since 1980. All the time, I've been a living creature. Okay. Compare that with like caterpillars and butterflies. Okay. I took those pictures. I'm not sure that this kind of butterfly exactly comes out of this kind of caterpillar. But those things, they are identical in the sense of particulars. They carry identity. Okay. So I had a identity card in these days, and I still have that identity card, which proves that these two things here are the same particular, carry identity. The same holds for these things here. Okay. But it changed quite a bit. Okay. So let's go again to talk again about the importance of temporal indexing, okay? Something which is totally ignored in mainstream ontologies. Imagine this situation, okay? So you have a patient, okay? And John has a tumor. And that tumor is a part of John's stomach. Now, John's tumor at time T1 is an instance of benign tumor. And at time 2, it's an instance of malignant tumor. At both times, John's stomach remains an instance of stomach. Okay. Now compare that with this situation. Okay. Here you have two tumors. You have John's tumor, which is at T1 a benign tumor, and you have John's carcinoma, also in the stomach. Okay, which is a malignant tumor. Okay. And both of them are in John's stomach, which at both times is his stomach. If you look now only at the top part here, okay? So imagine an electronic healthcare record where diagnoses are written down. And you will find, for instance, diagnosis of benign tumor at time T1 and diagnosis of malignant tumor at time T2. How are you going to make the difference with this situation? If you only have types, references to types in your electronic health record, okay? You can't, right? So that's why you also need to have references actually for the particulars themselves. If you just have an electronic healthcare record where you are offered even an ontology, okay, and you can pick the terms from your ontology and you can date even those things, okay, you cannot express the difference between this situation and that situation, because the only thing that you have are benign tumor and malignant tumor, and you can attach a date to it. Okay. This is something what led me to develop the theory of referent tracking, which we are not going to discuss in this course, but it's interesting to read if you are interested in it. Look for referent tracking and ontology online. So continuants in the BFO, these are all the continuants that we have. Okay, there are not that many, well, about 20, 25 or something, I believe, or 30. Okay, continuant on the top, and then the distinction between independent continuants, generically dependent continuants, specifically dependent continuants, okay, where we will go into some details of those. Okay, so the three major continuant types are the ones that I just listed. Okay, what are the differences between them? Well, generically dependent continuants, they are such that if one bearer ceases to exist, then the entity can survive because there are other bearers. Okay, the classical example is a PDF file. Okay, or take my slides. Okay, they are currently on my laptop here. Okay, and I will, after this event, I will post them in the on the web page for this bootcamp, and you can get them there. And from there, you can take a copy and put it on your laptop. Okay, so you have then the slide set that is on my laptop here, the set that is on the web page, and then the set which is on your laptop. Well, I didn't write 3 slide sets. And if there are, I don't know how big the audience is here, but if there are 40 and you all copy them, I didn't make 40 slide sets, right? So the slide set itself is a generically dependent continuant. Okay. Information content entities are the most typical case. For instance, also gene sequences. Okay, those are also generically dependent continuant because you find those same kind of things in different kind of entities. Specifically dependent continuants, you have qualities and realizable entity. So a quality of special type is relational quality. For the realizable entities, we have dispositions amongst with functions and we have roles. Okay, what are the differences? A quality is a specifically dependent continuant that, in contrast to roles and disposition, does not require any further process in order to be realized. Okay, so qualities are there. The color of my shirt is there. It doesn't need to be realized. Okay, realizable entity require that. Okay, so those are specifically dependent continuants that inhere in some independent continuant, which is not a spatial region, and is of a type, some instances of which are realized in processes of correlated type. Okay, well, that's a mouthful. What does that actually want to say? Well, look at this. Typical realizable entities are like the fragility of a glass, or the skill of a craftsman, or the role of a student, or the function of a heart. Well, processes in which they are realized are, for instance, breaking. Okay, if you drop a glass which is fragile, it breaks. Okay, or the skill constructing is a skill of a craftsman. Studying is the role of a student. Beating is the function of a heart. Okay, now clearly, okay, you do not need to have those processes. Okay, even if the glass never breaks. Okay, it's still fragile. Okay. Even if the heart is not beating anymore, okay, it's still its function. Okay, so those two, they are related. Okay, they are related, but you do not always need to have the process. Okay, ideally, you do not want to have the breaking and the stopping of the beating of the heart, right? So on the most realizables, we distinguish between dispositions and roles. Okay? Disposition is such, if it ceases to exist, then its bearer or the immediate surrounding environment is physically changed. Okay? For a role, that is not the case. Okay? If I retire in a couple of years, okay, I lose the role of instructor. But losing that role doesn't change physically anything in me. Okay. At the other hand, I have the disposition to die. Okay. So when I die, quite a bit is changed in me. Okay. That's the distinction between dispositions and role. Something has to change in an entity to lose a disposition or to gain a disposition, while to lose or gain a role, that is not the case. Were there questions about these continuants? Okay. So occurrence. There are 4 subtypes. So while the continuant hierarchy of the BFO is relatively well established for occurrence, it's not that much. So we have process, which are things that unfold itself in time. We have process boundaries, okay, which are the start or the end of processes. We have temporal regions, which are like portions of time. And now spatio-temporal regions, which is that combination of time and space, which is used like in relativity theory and so on. So let's talk about relational entities versus formal relations. There is a paper that has been written in 2005, what explains very well how relations are used in the BFO. It's called Relations in Biomedical Ontologies. Do not confuse that with what is currently called the OBO relation ontology. Okay, so originally, in the early days of the BFO, those relations were separate from the BFO. Now in the BFO, the relations come with the BFO itself. And the OBO relation ontology has been developed as a totally separate thing. So what are essentials in using relations or predicates, okay, like we use it in logic? You need to be able to distinguish what is denoted by relation in technical sense, like formal relation, from what is denoted by relation in non-formal language, like material relations. The differences between type level formal relations, particular level formal relations, and particular type level formal relations. This is obvious, of course, when we recognize like the major distinction between types and particulars, there need to be a relationship between them. And we saw already one, which is the instance of relationship, right? The arity and properties of formal relations is something that you need to take into account. Elucidation versus definition. Basic formal relations versus shortcut. And then the axiomatic characterization. And we will discuss them one by one. Okay. So the mainstream view on relation is this. Entities that glue together other entities. Okay. You have to distinguish between formal relations that hold between 2 or more entities directly without any further intervening individual. And then you have material relations, so they have a material structure on their own, which means that they are entities. Okay. So take this example. You have John, you have Mary, and John is friends with Mary. Okay. So here are the expressions. You have the sentence here. John is friends with Mary. And you have here the entities, John and Mary's friendship, and Mary. Okay. John is about John. His friends with is about his friendship. The term Mary is about Mary. Okay. So John and Mary in BFO are objects. John and Mary's friendship in BFO is a relational quality. So these are instances of these universals. Now, John and Mary's friendship inheres in John and inheres in Mary. Okay, inheres is the relationship that we use between qualities and objects. Okay, those are material relations. So they have structure on their own, are entities in their own right, relate other entities to each other by means of formal relations. Some examples are, like, for instance, patient, treatment, driver. Okay. Examples in BFO are relational qualities. Okay. They have independent continuants as their bearers, and there are also relational processes like kissing, buying, and so on, which require like two intervening things. When you buy, there is some selling, and so on. Relational qualities are explicitly mentioned in the BFO as different entity. Relational processes are not. We just have a process, which means that the BFO is not yet complete and will expand in due time. Okay. So formal relations, look at this. These were the material relations, the ones which are in the green circle there. And here are the formal relations. So inheres in this case, is a formal relation. Also, instance of is a formal relation. Okay. You have basic formal relations like ontological dependence, inherence, subtype of, part of, instantiation, and so on. And you have domain formal relations. Those are relations that exhibit similar characteristics. Okay, for instance, relations of comparison, like taller than, older than, knows more Greek than, and so on. In the BFO, primarily comes with those relationships. So we do not use any domain formal relations. That is because BFO is meant to be useful in all domains, okay? And therefore, it contains only those types and relationships which are relevant for all domains. So another characteristic, idearity. Okay, you have binary relations like my youth, part of my life. You have ternary relations, my hand, part of me now. Okay, you see exactly already the difference, right? If my hand gets amputated, my hand is not part of me anymore then. Okay. Quaternary relation, my left middle finger is between my left index finger and my left ring finger now. If you use full forced order logic, there is no limit on the number of arguments that a relation can have. Okay. So are relations in the sense of relation types. Okay, so relations do not come in types in the same sense that particulars come in types. Okay, but we can classify relations in certain ways, and these are ways that we do that. So instance level relations, instance type relations, and type level relations. Okay, instance level relations, for instance, your heart is a continuant part of your body at some time. Your heart beating as participant your heart at some time. Instance type, John's heart instantiates human heart at time. John's heart beating instantiates human heart beating at time. They have type level relations, for instance, human heart, continuant part of human body, human heart beating process as occurrent part beat profile. Now, features of relations on the level of instances may not hold on the level of universals. Okay, you will see that quite often some mistakes are made there in ontologies that you find on the web. For instance, nucleus adjacent to cytoplasm. That's correct. But cytoplasm adjacent to nucleus would not be correct. Okay, why not? Well, red blood cells don't have a nucleus. They do have a cytoplasm, right? But they don't have a nucleus. So if you would put as a generic statement that the nucleus, all nucleuses, you have to interpret it that way, or more correctly, all nucleuses are adjacent to some cytoplasm. That's how you actually need to read those relationships. So if you would make that statement, that's correct. But if you would say all cytoplasms are adjacent to some nucleus, that's not correct, because red blood cells. This is another example, okay? It is okay to say seminal vesicle adjacent to a urinary bladder. It is not okay to say urinary bladder adjacent to seminal vesicle. Why not? Who can tell me?
Women don't have a seminal vesicle.
That's correct. So adjacency is a relation between universals, but it is not symmetric at that level, while it is symmetric at particular level. Okay. Again, that important distinction between particular and types. So if you have something, some particular whose urinary bladder is adjacent to the seminal vesicle, then his seminal vesicle is adjacent to the urinary bladder. Okay. So at particular level, the relationship is symmetric. At universal level, it isn't. Okay. So that's why you need to read those things always in using the all sum, okay, predication. Okay. A's part B needs to be read as all instances of A are instance level parts of some instance of B. Okay. That is if you do it timeless. Okay? If you do it with a time, then you need to add that in it. A has participant B. Okay, all instances of A have some instance of B as instance level participant. Okay, cell binding has a participant cell. Okay, you cannot have a cell binding if there is no cell involved. Okay, but you can have a cell which is not involved in cell binding. So that's what we call the all sum part. Okay, in the BFO, you have A continuant part of B, okay, in the OWL version, but the semantics is for all particulars A and times T. If A is an instance of the universal A at T, then there is some instance of B of the universal B, such that A is an instance level part of B at time T. Okay. If you look at the first order logic axiomatization, then you will see that continuant part of at universal level is also indexed, is time indexed. In the OWL version, you don't have that. Now you might say, yeah, we know you said that already 50 times. Well, I will say it another 50 times because you will need to be aware of it, okay, that distinction. So I said, you see sometimes if you read the manuals or the documentation of the BFO, that sometimes we use the term elucidation, sometimes we use definition, okay? If we use the word means here, that's an elucidation, okay? X is about Y means X refers to or is cognitively directed towards Y. We specify the domain, so representations, we specify the range, portion of reality, and now we give an axiom. If X is about Y, then Y exists. So that's the requirement of veridicality. In the sense, if Y does not exist, there cannot be an aboutness relation between X and that Y. Now, if you have A means B as a term, okay, which is an elucidation, then if A is the case, you can conclude that B holds. If B is the case, you cannot conclude anything with respect to A. So that's the definition, the difference with the definition, okay, which usually we note it like this, is def, okay. Example is a representation of, X is a representation and X is about Y, where Y is a portion of reality, okay. Note that not all representations are about something. So in this case, this means if A is the case, you can conclude that B holds. If B is the case, you can conclude that A holds. If one doesn't hold, the other one doesn't hold. avoid at all cost X has Y, okay? Do not write relationships like has symptom for, oh, disease has symptom, symptom. Object has temperature, temperature, okay? That's not good practice, okay? Unless you define such relations explicitly as shortcut relations. Shortcut relations are when you have a big series of relationships that need to come together and it is too cumbersome all the time to write that out explicitly, then you can make shortcut relations. Right, that's what I wanted to say about the BFO. So we do have time to go into the ontology for general medical science, unless there are questions. No? Okay. One remark. So BFO started to be developed at the end of the 90s. Okay, first version I think was 2001 or 2002. We are now 2026. So that's 25 years in development. For about 37 entities, and don't know how many relations there are. I think maybe 20, 25, something like that, not counting the inverse relations. You will say that's not much. No, it's not much, but it's developed with a lot of people, requiring a lot of thinking to get everything correct. So don't think that you as an individual, okay, can develop an ontology with 2,000 or 3,000 of entities, okay, in 2 or 3 weeks. If you do that, then it's guaranteed you didn't think it through, okay? Or actually you are not building an ontology, you are just building a classification or a terminology. So, OGMS, Ontology for General Medical Science. So the basis is actually here. It's the classical story of what happens with patients and when they go to see a clinician. So usually at some point or up to some point, patients, they are healthy, okay? And then some disorder develops in their body, okay? So originally they are not aware of it, okay? So that's when it's called a preclinical manifestation. The term itself is a little bit funny because there is no manifestation at all, right? Even the patient might not be aware of it. But at some point, indeed, the patient might become aware, okay? And then he goes to see a doctor and complains about pain. And then the doctor asks, where is that? There, and he shows it. And then the doctor palpates the body and he might find something, okay? So he might observe that there is indeed something in the stomach there. Either he can feel it when it is like a tumor, or when he presses, it causes pain, okay? So we built here what we call a clinical phenotype, okay? So you need to do a lot of exams there, okay? Physical exams can give you those manifestations, but you can also do technical exams. The idea is actually that the doctor, on the basis of the clinical picture that he develops, okay, can come to a diagnosis, and on the basis of the diagnosis can make a plan to provide a treatment, and then do the follow-up to see what is happening with the patient and whether it is helping. It's no coincidence that these parts here are divided by this blue barrier, because what we mean here, okay, here you have reality, okay, and here you have the representations, okay. Clinical pictures, the diagnosis, and the plans, they are actually representations of what is the case or has been the case at the level of the patient. So the main part of the OGMS is actually the distinction between disease and disorder. So a disease is a disposition. Remember, I explained to you what a disposition is. Rooted in a physical disorder in the organism and realized in pathological processes. The chain that you get is then this, okay? So you have an etiological process, let's say like a car accident or whatever, or a bacterium that gets in your bloodstream. So that produces a disorder. With the disorder comes a disposition. If you are unlucky, then that disposition is realized in pathological processes. These pathological processes produce abnormal bodily features like pain or redness or bleeding. Okay, they are recognized as signs and symptoms. The signs and symptoms participate in an interpretive process, and that produces a diagnosis. Okay, so we gave definitions to those things. Okay. A disorder defined as a causally relatively isolated combination of physical components that is clinically abnormal and maximal in the sense that it is not part of some larger set combination. Any idea why that maximal criteria is there? So if you have, let's say, a liver tumor, how many cancerous cells are there in a liver tumor? Many. Thousands, right? Well, you don't have 1,000 disorders. So that's the idea, okay? So cancer starts typically with one cell, and then that cancerous cell is a disorder. And then the cell multiplies, okay, it starts to grow. At that point, it's not each individual cell that is a disorder, it's the combination of those cells, okay? If those cells form a tumor, okay, like in a liver tumor, then that tumor is the disorder. If you have a disease like leukemia, there is no tumor there, but it is that collection of those cancerous cells, okay, they are the disorder. Clinically abnormal is used, right, in this definition of disorder, okay? Something is clinically abnormal if it is not part of the life plan for an organism of the relevant type, okay? So aging is not clinically abnormal. Pregnancy is not clinically abnormal. Well, most people don't consider it like that. I always say that when you are pregnant, then women have the only malignant tumor that they are worried about. Okay. Second condition, causally linked to an elevated risk either of pain or other feelings of illness or of death or dysfunction. Okay. Now, pregnancy is causally linked to an elevated risk of either pain and so on, right? But it is explicitly excluded already here. Secondly, is such that the elevated risk exceeds a certain threshold. That's the definition of clinical abnormal. Okay. Now, disease. Disposition to undergo pathological processes that exist in an organism because of one or more disorders in that organism. Pathological process is a bodily process that is a manifestation of a disorder and is clinically abnormal. Disease particulars can instantiate distinct universals at distinct times. Okay. You remember that I gave that picture of me as a baby and then as an adult later. I changed over time. Diseases also, okay? So think of coronary heart disease. You have a guy, John, who has a coronary heart disease. Well, early in time, this coronary heart disease instantiate disease associated with early lesions and small fibrous plaques. And doctors will have a name for that, right? And then disease associated with asymptomatic or silent infarction. And now you get surface disruption of a plaque. You get unstable angina, you get stable angina, okay? So it is one disease. John didn't have 5 diseases over time. It's just one disease, okay? But the disease evolves, starts to instantiate different kind of universals. But all the time, it's of course coronary heart disease. We introduced the notion of a disease course, that is the totality of all processes through which a given disease instance is realized. And we have diagnosis, which is a conclusion of an interpretive process that has as input a clinical picture of a given patient and as output an assertion, for instance, a diagnostic statement, to the effect that the patient has a disease of such and such a time. Okay. So a clinical picture, okay? Clinical picture is a representation, okay? All the definitions here, okay, except for diagnosis, right? Those three here, including pathological processes, they are in your body if you are sick, okay? Clinical pictures are not, okay? They are representations. Where are those representations? Well, they can be in the head of the clinician, can be in the head of the patient, can be in an electronic medical record, in a discharge letter, whatever, okay? So its representations are information content entities. There's a paper here that you can read and that specifies that. And information content entities, like we said, they are generically dependent continuums. Important part of the OGMS is that there is no conflation between diagnosis, disease, and disorder, okay? There are some classifications which have a name like classifications of diseases and diagnosis, okay? We distinguish disease from disorder, like you saw. Okay, SNOMED CT doesn't do that, okay? So everything there is under the disease hierarchy, but I think between parentheses, they write disorder. So, which means that things like tumors, which are actually continuants, and atrial flutter, which is a process, they are all under the same umbrella, okay? In OGMS, because it follows the BFO, they are separated. So diseases are distinct from disorders. Diseases are dispositions. Disorders are material entities, and diagnoses are representations, so generically dependent continuants. And either way, diagnoses, they are about disorders. They can be about the wrong disorder type, right? But they are nevertheless about something. So it's SNOMED CT, like I said, if you go to the diseases, you see they have disease, and then between parentheses disorder, and you have a mixture of things which are tumors, which are processes, and so on. Even more surprising, and I touched upon that on the basis of a question on Monday. So you see, diseases here are clinical findings, which by itself is absurd, because diseases exist without being found. Okay, there is no need to find a disease for there to be a disease. So the upper structure of SNOMED CT is not really designed according to realism-based principles. It's rather based on experience, no, not experience, but with how clinicians are used to talk about patients and the material that they are working with. Okay, that's more the basis for SNOMED CT. Some people have tried to link SNOMED CT to the OGMS, which has been published, but it's totally wrong. Okay, so a couple of the things are right, but most of the relationships that are made here are absolutely wrong. Simply because that distinction between disorder and disease is not used. You see here, for instance, they say clinical finding disease in SNOMED CT correspond with disease. You see the equivalence sign here. It's of course totally wrong. There are a couple of bad disease ontologies, despite being listed in the OBO Foundry, like the DOID, for instance, is bad. Mondo, I mean, it's a classification. Okay, it's not an ontology. Semantic science ontology is a completely incoherent foundation. You find them referenced several times. My advice is really don't use them, because they do not have any good foundations. And that's what I wanted to say. And once more, I did it in time. Are there any questions? No? Okay, then I'll see you tomorrow. And then tomorrow we are going to work on how to write indeed some simple axioms, make them a little bit more complex towards the end. And we are going to work specifically on that example of those patients with their persistent idiopathic facial pain and how to represent those distinctions. All right, thank you for being here, and see you tomorrow. Bye-bye.
Thank you.
Thank you, bye.